So suppose that we're doing this. Suppose that we have the segment 0, 1, so the set of real numbers greater or equal to 0 and smaller or equal to 1. And we want to describe a mechanism for picking one of those points at random. Can anyone describe a method that someone could use? I mean, in principle and idealizing about what can actually be done in practice. Can anyone think about a method to do it? So a hint is that you might use, oh, OK, you have a proposal.
Does it need to be in finite time? Or?
Try it with infinite time, and we'll see what happens.
You can express it as like a decimal number, and for in binary as like a binary.
I like it already. OK, so sorry, I'm going to interrupt just to explain that, and then you will continue. OK, so that's right. So for any number in there, you can express it as an infinite sequence of zeros and ones following 0 point. So a 1 there means 1/2, a 1 there means 1/4, an 1/8, and so forth. So for example, 1/2 using this notation would just be 0.1. And something that's very easy to verify is that every number in here has an expression using this notation. In fact, there are some members in there that have 2 different expressions using this notation. So sorry, that was just glossing your first remark. Go on.
And then you can go through each index and flip a coin for either a 0 or 1 in those situations to get a real number.
I love it. I love it. So just infinitely many coin tosses. Each toss is going to decide whether a particular position gets a 0 or a 1. I think that's great. There's a geometrical way of thinking of this, which is equivalent. So you could just take the 0, 1 line segment, and then use the first coin toss to decide whether the point you're going to pick is going to be the left half or the right half. And then say that you choose the left half, and then use the next coin toss to decide whether you're going to pick the left half or the right half of what you're left with. Say it's going to be the right half, and so forth. OK, so we have a cool method for picking a point on the line. Now, a nice feature of this method is that if you take the line and choose a segment of length L, then you could prove the probability that the selected point will be in L is L. So for example, if you ask, OK, so what's the probability that you'll pick a point which is between the 1/2 point and the 1/4 point? The answer will be 1/4.